and directory in Linux has two identifiers attached to it, the UID of the owner and the GID of the group. When a process tries to access a file, the kernel runs a sequential check. First, it compares the process effective user ID with the file's owner and applies owner permissions. If that doesn't match, it checks the effective group ID against the file's group, and if neither match, it falls back to the permissions defined for others. This answer, every use, gets exactly the access level they're entitled to, nothing more.
These three permissions behave differently depending on whether they are applied to a file or a directory. For files, read allows opening and viewing content. Write allows modifying or truncating it, though it does not grant the ability to delete or rename the file, since those operations are controlled by the containing directory, and execute allow the file to run as a program. For scripts specifically, both read and execute must be active simultaneously, since the interpreter needs to read the instruction to process them. For directories, the semantic shifts entirely. Read allows listing the names of the contents with ls. Write enables creating, deleting, and renaming files inside, but only when execute is also active. Execute, often called the search bit, allows the user to enter the directory with cd.
chmod, short for chmod, is the command used to modify permissions on files and directories. It supports two notation. Octal notation works in base 8 and is absolute. It replaces the entire permission set in one operation. Each permission has a fixed value. Read is 4, write is 2, and execute is 1. You add them per category. For example, chmod 755.5.sh gives the owner full control with 7, and as it's read, would execute the group and other Wi-Fi. This is ideal when setting a no configuration from scratch. Symbolic notation is real-time. It's modified a specific bit without touching the rest. It's built from three parts. Who is affected using U, G, O, or A. The operation using plus, minus, or equal, and the permission using R, W, or X. For example, chmod U plus X script.sh and execute only the owner, leaving everything else intact.
Umask is a bit mask the shell applies automatically every time a new file or directory is created. Unlike chmod, which assigns permissions positively, umask works subtractively thrown at non-operations. The bits set in the mask are the ones removed from the resulting resource. The system starts from two base values, 777 for directories and 666 for files. With a umask of 0022, a new directory gets 755 and a new file gets 644. Files start from 666, not 777, for a deliberate security reason. The system excludes the execute bit from the file creation base to prevent any downloaded or generated file from accidentally running as a program.
This distinction reflects Linux technical separation between transit write and visibility writes. The execute bit on a directory tells the kernel that the process is authorized to traverse it and resolve paths to the inodes of its contents. So, if a user knows that exact name of a file inside, they can access it directly even without read permission on the directory, because X is inode to resolve that specific inode. Read permission, on the other hand, is what allows the system to read the directory's internal structure as a list of names. Without it, it simply fails.
To correctly configure a shared directory between Anna and Luis, the first step is establishing a common group identity. Create the group music with group path and add both users with user mode -A and -G music. This is essential because Linux evaluates group access by comparing the process effective GID with the resource GID, then assign ownership with the sudo chown root music path music, leaving root as the directory owner to prevent accidental deletion, and the music group as the content manager. Finally, apply chmod 775 to give the owner and group full RWX access, while others only get read and execute.
However, this base setup has two problems that special permissions solve. The first is group inheritance. When Anna creates a file inside the directory, it inherits her personal primary group by default, now music, meaning Luis won't have root right over it. Activating set GID with chmod G plus S fixes this. Every new file or subdirectory created inside will automatically inherit their directory GID, keeping both user inside without manual adjustment. The second problem is unauthorized deletion. With 775, any group member can delete any file inside, even files they don't own. The sticky bit solves this. With chmod plus T, activate only the file's owner, the directory's owner, or root can delete or rename it. The final configuration is chmod tier 775. Additionally, both users should set their umask to 0002 so that newly created files are born with write permission, making collaboration seamless from the start.